Here we have a problem on derivative. Okay, let's go to the information. So we have a function over here that is e to the y power equals to x times y square. Find dy by dx. Actually, it is an implicit function because it is not solved for y in terms of x, something like that. Y is equal to x square positive for x. Actually, so the function which I have written in blue color is solved for y in terms of x. So this is called explicit function. But the one we have in our original problem, that is e to the y power equals to x times y square, is not an explicit function. It's called implicit function because it has not been solved for y. Anyways, we have to find dy by dx. That is, we have to find the derivative of y with respect to x. Okay, so what we can do is we can find derivative on both sides with respect to x as it is in the given function. But here, when I look at the stuff on the left side, we have the variable y at the exponent. Usually when we have variable y at the exponent, particularly for the base, which is a constant, that is e, so it is advisable to take natural logarithm on both sides and continue the derivative process. Because if I take natural logarithm on both sides in this kind of functions, it will be easier for me to get the derivative. So the reason is the base is a constant, particularly the mathematical constant t, and the exponent is variable y. Okay, in my first step, what I'm going to do is I'm going to take natural logarithm on both sides of the given function. First, let me write the given function as it is. That is e to the power y equals to x times y square. So then I'm taking natural logarithm on both sides. That is ln of e to the power y equals to ln of x times y square. Okay, so now here I can use the power of logarithm. That is, whenever the argument is exponential, the exponent over here can be moved in front of the logarithm and it has to be multiplied by the logarithm. Then I'm getting y times ln e. And here, in the argument of the logarithm, two quantities are multiplied, x and y square. So whenever two quantities are multiplied in the argument of the logarithm, we can use a product of logarithm. That is, we have to take logarithm for each quantity and then we have to add them. That is ln x positive ln y square. So this is the reason I just want to take a natural logarithm on both sides, because I can use a properties of logarithm. When I use the properties of logarithm, so I'll be able to split up the terms in the given function. When I split up the terms in the given function, so the process of finding derivative will be easier. Okay, and also the value of ln e is just 1, because for a natural logarithm, the base is e. But I have not mentioned the base e. So whenever I write the spelling ln, it's natural logarithm and its base is e. So in a logarithm, if the base and the argument are same, its value is just 1. So this ln e becomes 1. 1 times y is just y. I get ln x positive. I can use the power of logarithm. That is, the exponent over here can be moved in front of the logarithm. Then I'm getting 2 times ln y. Okay, now I can find the derivative with respect to x in this one easily. Let me write. So differentiate with respect to x. Okay, when I find derivative of this y with respect to x, I'm just getting dy over dx. And the derivative of this ln x is, whenever I find derivative of a natural logarithm, I have to write 1 in numerator. In denominator, whatever argument I have for the logarithm, it has to be written in denominator. So far I have completed the derivative only for the natural logarithm. By chain rule, I have to do further derivative for the argument x with respect to x. What will it become? It's just 1. So even if I times it by 1, even if I multiply this 1 over x by 1, it is still 1 over x. So we don't have to mention the times by 1. Positive. So 2 is a constant multiplied by the variable. So when I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is. When I find the derivative of this natural logarithm of y, I have to write 1 in numerator, and the argument of the natural logarithm should be written in denominator. So far I have completed the derivative only for the natural logarithm. So by chain rule, I have to do further derivative for this y, argument y with respect to x. Then I am getting dy over dx. Okay, let me continue the stuff over here. I am getting dy over dx equals to 1 over x positive. So when I multiply 2 and 1 over y, I am getting 2 over y times dy over dx. My aim is to solve for dy over dx. So better we can get the terms which contain dy over dx on one side of the equation, that is on the left side. Already we have a term which contains dy over dx on the left side. So now we have to get the term which contains dy over dx on the right side. For that, I have to subtract 2 over y times dy over dx on both sides. Let me finish. Negative 2 over y times dy over dx. Then the positive stuff, negative stuff will cancel out. On the left side, I'm getting dy over dx. Negative 2 over y times dy over dx equals to just 1 over x on the right side. Now I can factor dy over dx from the terms on the left side. Then if I factor dy over dx, then I have 1 negative 2 over y inside the parenthesis. Okay, even if I distribute this dy over dx to this one and this one, I must be getting the original stuff over here. Okay, so when I distribute this one to 1, I'm getting dy over dx. When I distribute this one to this, I'm getting this stuff. Okay, so dy over dx, let's simplify this one. Okay, I mean, let's simplify this 1 negative 2 over y. Okay, so to simplify, I mean, here we have a subtraction between an integer 1 and a fraction. Whenever I do addition or subtraction between an integer and a fraction, the integer part has to be multiplied by the denominator of the fraction. So there's 1 times y. When I multiply this 1 and y, I'm just getting y. So once I'm done with this multiplication, I can take this y in as a common denominator. Okay, so when I multiply this integer part 1 by this denominator y, 1 times y is y, negative, and we can take this one 2. And now we have to write this y as a common denominator, so equals to 1 over x. Okay, now my aim is to solve for dy over dx. So first let me write this equation as it is. It is dy over dx times y negative 2 over y equals to 1 over x. Okay, to solve for dy over dx, what I need to do is I have to multiply both sides by the reciprocal of this stuff. That is y over y negative 2. Let me do it. I multiply both sides by the reciprocal of this y negative 2 over y. That is y over y negative 2. So this y negative 2, y negative 2 will cancel. This y will cancel out. So I just have dy over dx on the left side. On the right side, 1 times y is y. And in denominator, x times y negative 2 is x times y negative 2. So now I got the derivative of the given function with respect to x.